The largest planet in the solar system, and second most massive object after the Sun, is Jupiter. It boasts at least 79 moons, and the 4 largest of these, the Galilean moons, would all class as small planets themselves if they were orbiting the Sun instead. So does that mean that something like our own planet could ever become a Jovian moon too? This is Unveiled, and today we're answering the extraordinary question, could Earth orbit Jupiter? Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. Although some of Jupiter's moons are large, none are larger than Earth. The largest, Ganymede, which is also the largest moon in the solar system full stop, is though bigger than the innermost planet Mercury. So we already know that Jupiter can play host to planet-sized objects in general. In the layout of our particular star system, much depends on the distance an object is from all other objects that could exert a gravitational influence over it, and balancing that with how far out that object is from the Sun. So size is important, but it isn't make or break in terms of what can orbit what. We see across the universe that objects of essentially any size can safely orbit each other, whether it's the dwarf planet Pluto, which has at least 5 tiny moons, or the 2 massive central expanses in a binary black hole system. Physically speaking, Earth could, at the right distance, under the right conditions, orbit Jupiter, but it would mean major upheaval in the solar system. But what about orbiting Jupiter and retaining life? It's nowhere near as simple. Despite its impressive size, Ganymede is still very unlike Earth, and one reason why is that it has such an incredibly weak atmosphere. A handful of Jovian moons at present do boast an atmosphere of some sort, but most don't. And of those that do, none are even close to Earth's. We see in other planets like Venus, which is clogged with CO2, just how important atmospheric conditions are, and we know that life can only exist on Earth because its own atmosphere is just right. So were Earth to orbit Jupiter and still host life, it'd have to somehow keep hold of its life-enabling atmosphere too. The nearest match in terms of Jovian moons with the potential for life is thought to be Europa, but even it has a very thin atmosphere. Europa, though, is still often touted as mankind's best bet for a second home anywhere in the solar system, or even as a potential source of alien life, with various claims that extraterrestrial somethings could be thriving in its subsurface oceans. It's the predicted presence of liquid water that's key here, suggesting that parts of Europa must be reasonably temperate, not too cold to freeze all the water, nor too hot to evaporate it. And in an alternate world where Earth did orbit Jupiter, if life were to stand any chance at all of surviving, then this would be another of the most important requirements to make it happen. We know that Earth, as it is, resides in the habitable zone of the solar system, at just the right distance away from the Sun for water and life. But if there are subsurface oceans on Europa, then there's something else at play, another means to retain warmth, with most explanations leaning toward tidal flexing. Presumed to be what's happening on some icy moons like Europa, as well as on Saturn's Titan, tidal flexing is when a big enough planet's strong enough gravity creates the motion of the tides on its moon. That motion then creates heat through friction, which, in the case of Europa, ensures that subsurface oceans stay liquid. Jupiter does also emit a certain amount of heat of its own, but nothing even closely comparable to the Sun. So tidal flexing could be key to how Europa works, and if Earth were to wind up in a similar position, it'd be crucial for its survival too. With or without tidal flexing though, the change in distance from the Sun would certainly cause turmoil in how our planet fundamentally works. Rather than trying to curb global warming, for example, orbiting Jupiter would mean we'd be desperately trying to increase it, to top up on heat by any means necessary. Not that humans aren't capable of living in extremely cold environments. One of the coldest continually inhabited places on Earth is the village of Oymyakon in rural Russia, where winter temperatures have been known to plummet to -90 degrees Fahrenheit. By contrast, Europa's oceans are warmer, or else they wouldn't exist. Io, another of Jupiter's moons, a volcanic one, is also known to be hotter, although the trade-off is that Io is also noted for producing high volumes of deadly sulfur. Were Earth to suddenly orbit Jupiter then, we'd have to find a way of making heat without risking the air we breathe. A difficult, potentially impossible task, all while finding a way of maintaining an atmosphere thick enough to protect against radiation, including increased radiation from Jupiter too. And there aren't many solar system objects at all with an atmosphere thick enough for that. And so we're back to the problem of atmosphere. because even were the sun and planets to realign so that it was physically possible for Earth to orbit Jupiter, would it still resemble Earth if it did so? More than likely not, but that doesn't mean that there aren't some moons out there which could still be Earth-like. For most astrophysicists, because moons are so common in our own star system, the existence of exomoons, moons around exoplanets in other star systems, is generally a given, even if it is debatable whether we've actually observed one yet. The problem in studying them is that exomoons are generally too small, or too far away, or too complex for us to identify with confidence. But it is at least plausible that somewhere out there in the universe, there's a gas giant, like Jupiter, with a rocky moon, like Earth would be, at just the right distance from its star, holding alien life. Much as life on Earth relies on the current balance of this solar system, it'd all depend on that exomoon existing in life-enabling equilibrium with everything else around it. For the same thing to happen to a hypothetical Earth around Jupiter, well, the chances aren't great at all. Yes, it's physically possible that an object the size of Earth could orbit around an object the size of Jupiter, but the fundamental makeup of a Jupiter-orbiting Earth would almost certainly be totally different. And the question of how Earth would get to its new location, what would send it on its way, and could it ever hope to survive such a journey, is one for another video. Perhaps in a far-off future, we'd even have tech advanced enough to purposefully move planets into whatever position suits us best. To the point where, in some kind of Kardashev Type 5 society, the question wouldn't be could Earth orbit Jupiter, but remember when it did? For now, the prospect of something the size of Earth around Jupiter is something which could happen. The likelihood of it happening and Earth still retaining life, though, is incredibly small. Between here and there, this world would simply have to go through too many changes. So we should thank our lucky stars that we're not Jupiter-bound, just yet. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.